the record button. So today's session all about questions, right? And so first question, what are we allowed to bring to the exam? You can bring a writing utensil and a calculator. Everything else will be provided for you by the testing center. When you go in, you just tell them what class you're in and give them my name. And that will allow them to pull up the password. So you will go in through Ivy Learn into Module 5, click on the exam, and it's going to prompt you for a password, and then the testing center people will type in the password, and they should give you scrap paper, and then you can work through the problems. When you finish, you hit submit, right? That turns the test in, and then you give them the scrap paper, and they scan that to me. That way, when I grade it, I can have your scrap paper and give you partial credit. But the only thing you need is a writing utensil and a calculator. And that should be it. Where do you find where you scheduled your, did you already schedule it? Oh, okay. I'm gonna have to think on that. If, okay, so if we go back into the Student Resource Center, I'm wondering if it's in the same spot. I honestly don't know, but since I'm on, we can kind of dig through this. So testing services, open a new tab. Let's see. I mean, you've already, maybe if you go, I know you, if you've already scheduled it, I don't have a login. Go back to where you go in and go ahead and re-log in and see if there's a button. There you go. Yeah. If you click on that, you can see underneath schedule an appointment on the left here, it says view appointment history. And that will allow you to, it'll show you, not completed. This is mine and it was completed. Yeah. So go back in like you're going to set up an appointment, and then you can just view appointment history. Woo! 2 for 2. And if that doesn't work, you can always call the testing center. Whatever campus you're going to, just call them. That would work. No problem. Have you both already done the practice test? Have you worked through that? No. I would recommend, do you know where to find that? Maybe that should be my next question. So let me go into our course. Okay, you do know where to find it. Good. Even if you don't do the whole thing, I think that is just so you can kind of get a feel for, the variety of questions. So under the learning activities, it gives you basic topics, but this review packet, it's pretty exhaustive. It's got a little bit of everything from the first 9 sections, and that's really, I mean, you want an overarching, review. So, ratios, scientific notation, proportions. You're going to have a little bit of everything, per capita, all of that fun stuff. So, and that's why I always say if you can do this, you'll be fine. A little confused by 3B. Oh, I think, yes, that is a horrible question. I'm actually going to make a note to myself to redo. This practice test needs to be updated anyway. But this question is horrible. So when it talks about how many times further away the Earth is than Mercury from the Sun. So basically, they're saying if we would take Mercury, because Mercury is farther away, or is closer, Mercury times some unknown value. So Mercury times X being the unknown, is going to give us Earth. So how many times further away is Earth? So what is that value of X? What do you multiply Mercury by to get Earth? All right. Well, if you think about how would we get X by itself, going back to like solving our proportion type thing, we would divide both sides by mercury. So that would give us our value of x equals Earth divided by mercury. And so thinking through that, you can go back and say, okay, well, here's the Earth, so that number goes on top. Here's mercury, that number goes on bottom, and there's your ratio. So you can think of it as an equation, you can think of it as a ratio. Either way, you end up with Earth on top of mercury, and when you divide them, you end up with the factor that you would multiply mercury by in order to get Earth, which is very poorly worded indeed. That's kind of a good thing, just to kind of go through and look at some of these and see which ones make sense, which ones don't make sense. We can talk about them as they come up for you. We can scroll through. So yeah, I'm just going to sit here, for this hour, and you can ask questions as they come up. You don't have to talk. We don't have to talk the whole time. We'll just be live. That way, if you have a question while you're working through this, I'll be here live to help. Or you can ask solid for an hour, whatever you guys want to do.
Can I talk and try and explain it? It might be a little bit easier.
Absolutely.
Okay. On 3B, I get what you were saying to divide Earth by Mercury, but okay, the answer that you get in 3A is 1.496 times 10 to the 8th for Earth, and then 5.791 times 10 to the 7th.
Right.
And then I know that when you divide, you have to subtract the 10 to the 8th from 10 to the 7th. And so is that just 10 to the first, or is it just 10?
10 to the first. Well, 10 to the first and 10 are the same. So 10 to the first power is the exact same as just 10.
Okay, and then when you divide the two, you get 0.2583 times 10, but I know you have to make it to 2.583. So, and the answer key says that it's 2.583 times 10, but I was thinking that it should have been 2.583 times 10 to the negative first, and so that's where I kind of got confused.
The answer key says it should be 2.5 times 10?
I believe so.
Oh, then there's a problem. Trying to see if this comes up. Well, that would make sense why you're confused. Okay, so here's the answer key. It's 0.258 times 10.
So would the real answer be 2.58 times 10 to the negative first? Like, is that how we should answer?
No, if you're going to go at this point, okay, so if we're looking here in green on this page, if you say, okay, I'm now going to go to standard form, right? Because if we're talking about how much further something is, we're never going to talk about that in scientific notation. So standard form says if we have an exponent of 1, right, we move our decimal one place over. So that would just make it 2.583. That's it. Once I change it to standard form, the times 10 to the whatever goes away. So you just and you can round that. The answer key rounds it to 2.6. So this would say the Earth is 2.6 times further away from the sun than Mercury. Earth is 2.6 times further away from the sun than Mercury. That's what that 2.6 means.
Okay, now it makes sense. Thank you.
Yeah, no problem. No problem. It's a poorly worded question, and then the answer key is also a little bit poorly worded. So you put those together and you have confusion. One thing I want to say about the exam, just in general, is don't overthink the problems. That tends to be an issue for some people. When you read it, especially if you've done the work to prepare, when you read the question, go with your gut. Whatever your gut tells you to do with a problem, go with it. People try to, add extra things onto problems. Just follow the directions, exactly what it says. Don't make any more of it than what it is. So just really try to simplify that and keep it, I don't know, I don't want to really say keep it simple, but really don't read any more into the questions than what's there. Just really go with exactly what it says and that's it. So people want to make it harder than it is. I don't recommend that. The name of a number with 9 zeros, 9 would be billion. So if you're thinking through, so this would be 4 billion because 9 is the B. If there are just 6, that's million. And if you go the other direction where there's 12 zeros, then you have trillion. So million, 6, billion, 9, trillion is 12. There you go. That's a good way to think of it. Never heard that one before. 25, absolutely. So let me erase all of this. 25. Okay, so this is the one that you're talking about, right? The Ivy Tech head counts for fall. Oh, I sent you the one that I did in my class. Okay, let me bring that one up. Wrong button. Give me 2 seconds. Practice exam 1. Okay. Okay, so the GPA is this one. So did you want GPA or the weighted average? Or the percents? Or both? Both. Okay, let's start with the GPA first. All right, so thinking about anytime you're doing a weighted average, whether that's GPA or percents or counts or whatever, you always want to think about you have to add a third column. And I talked about it in class as that third column. I always call it quality points, right? You got to have a title. And when you're talking about a GPA, GPAs are found by these points, right? Points are based off the grade. So in English, if you got a C, you earn 2 points per credit. So to find our last column, we have to multiply credit times points. So 4 times 2 means you earned 8 total points for English. And for philosophy, 4 and 4. So I take 4 times 4, and I've earned 16 points for philosophy. For science, I've earned 3 times 2, right? So 3 and 2, which gives me 6 points for science. And then my success seminar, I'm just going to take 1 times 3. Now, anytime we're doing, weighted average, we have to total things. And when you think about the GPA, your GPA is calculated by your total quality points. And total quality points is always going to go on the top. And in the bottom, we're going to divide by our total credits. Because the more points you can earn in the fewest amount of credits gets you the highest GPA. So in this case, when I add my total quality points, what do I get when I add those 4 blue numbers together? $33, exactly. So you've earned 33 total quality points. Well, we also have to know how many credits we're taking. So how many credits did this person attempt? 12. Exactly. So when we go to find the GPA, quality points is 33, credits is 12. And when I divide those, that will give me my GPA. Yep, exactly. So the GPA for this particular problem, when you divide those, 2.75. Yep. And if you think about it, all of the points earned were between 2 and 4. So you know your GPA is going to be somewhere between 2 and 4. Can't be less than 2, can't be bigger than 4. It's going to be somewhere in that range. But the thing that people always forget is that they have to come up with that last column. And that's for both types of weighted average. You've got to come up with that last column, and that column is always created by multiplication. So we want to multiply our credits and our points together to get our quality points. All right. Does that one make sense? All right. So let me clear that. We'll go to the next one. Oh. All right, so now we're in the percents. And again, we want to come up with another column. Again, I always call it quality points because I'm lazy. And that column is formed by the multiplication of our category average, which is found here, multiplied by our weights in percents. So, for the homework, you're going to take your 75. 15% is 0.15 as a decimal. So how many points do we get from homework? 11.25, exactly. Now you're going to do that same thing for the other three categories. So we're going to take our projects times 0.2. We're going to take our quizzes times 0.2. 14, correct? And exams times 0.45. 16 is the next one. Good. And 36.9. 36.9. Okay. So now we're still going to take total quality points, but because we're dealing with the percents, we would divide by the total percent. Well, the total percent is 100%, and as a decimal, that's just 1. So we're going to take our total quality points divided by 1, which essentially does not change our answer. $78.15. So that would be the student's final percentage for the semester. Right? So for any kind of weighted average, you gotta have that third column that you multiply to find. and go from there. You're welcome. Skewed right means the highest part is on the left. Thinking about graphically looking at a picture, let me get it clean. If we have, here's my right, so small over here, big numbers over here. If you're talking about something that is skewed right, that means it's going to be high over here and tail off to the right. So highest part is on the left, the tail. You always want to look, where's the tail of the graph? That is the way it's skewed. So this would be skewed right, whereas if I drew something, let me draw a smaller one. Oh, come on, pen color. Something like that would be skewed left because the high part is on the right and it's tailing to the left. So you're looking at the tail of the graph to talk about skewness. It seems backwards, but that's why you always talk about the tail. The tail is where it's skewed. Yep, 34. Okay. All right. So, based on this information, has minimum wage increased more or less than the rate of inflation? So this is where you're going to have to play the what if game. All right. I wonder if I can copy and paste. So the answer to that is no. Okay. So basically what you're given here is that this is the actual amount for 2012. Anytime you want to see if something is kept up with inflation, you want to say, okay, we want to compare what the value should be based off inflation compared to what it actually is. We want to compare those two. So let me change color for effect. So we're going to take any of these 4 years, and it says 2 calculations, so we'd actually do this twice. But I'm going to start with 1972, and we want to compare 1972 to 2012 using our CPI proportional thinking. Meaning, in 1972, if our minimum wage was $1.25 with a consumer price index of 41.8, if minimum wage had kept up with inflation, exactly the same as inflation, our minimum wage would be X in 2002 with a CPI of 229.594. Right? So this red X is what it should be. All right, so go ahead and solve that proportion for what our minimum wage should be in 2012. $6.87. Okay, so if minimum wage only kept up with inflation, minimum wage should be $6.87, but it's actually $7.25. So now we're going to compare this, what it should be, to what it is. So did minimum wage, in all realness, according to these numbers, did minimum wage increase exactly with inflation? Well, that's an easy no because these numbers are not the same. So now you have to decide, did minimum wage increase faster or slower than inflation? Right? Exactly with inflation, it would be $6.87. It's actually $7.25. So did it go faster or slower? Faster, exactly. So that's what this one shows. Now, the reason it says provide 2 calculations, well, depending on what years you pick, you might get 2 different answers. So oftentimes we'll say, okay, let's do that same thing again, but now let's use 1981. So in 1981, the minimum wage was $2 with a CPI of 96.5. Still thinking, what should it be for 2012? And generally, you want to use your most recent year. And you would do the same thing. You would solve this proportion. So 2 times 229.594. Okay, so if we look at it, 2012 compared to 1981, minimum wage should only be 476. Again, in actuality, it's 725. So again, we prove mathematically that minimum wage has grown faster than inflation. So now we have two different years. And if you wanted to, you could do 1992 and 2002 to see if it holds true that it's continuing to grow faster when compared to the consumer price index. So that's just playing the what if game, and taking into consideration, multiple years so that you can kind of get away from a fluke if there was one year that was higher than another. Okay. And if you want to keep working, I'm going to be working in my office for a while. I can keep this on so you can keep asking questions. So we don't have to quit at 2 o'clock because I'm going to be here anyway, just working for a while. I don't know what you have planned, but you can stay as long as you want. I do need to run to the restroom, so I'm going to stop this, but feel free to stay on. I won't close it out until you're done and ready to leave. So feel free to keep working and asking questions. I'll be right back.